So this lecture we will discuss that what are the processes which are going on the surface of the earth and how these processes can be used for a civil engineer. And in today's session, I'm having an interest to introduce this concept of using a geological knowledge for a civil engineering purpose. Okay, so what we are going to do today is that we'll see that what are the topic we are going to discuss. Then we'll briefly see some of the case studies what I have observed in the last few years. So that will help you to understand the importance of geological knowledge for a civil engineer. This physical geology is the term which represents the processes which are going on the surface, or it is modifying the surface or in the near subsurface. So there are number of activities which are going on the surface which modifies the surface of our earth. Like if you see the first image, which is a river which is flowing, then there is a volcanism which is happening. As a result, it made a volcano, and that actually changes the topography of the region. This is an activity of wind, a wind which deposited a large dune that actually changes the topography, the landscape of that region. This is an activity by a sea which actually changes the beach, and it deposited something. So if you see together all these things, whatever natural processes which are happening on the surface of the earth, it either erode something or it deposits something. Something means which is eroding the rocks on the soil or depositing the rocks on the soil, which actually creates number of geomorphological features. So the study of that all processes, we call it as a physical geology. It is either an external process like a river, wind, or a glacier movement, or an internal process like an earthquake or a volcanism. Correct. So these processes are continuously active since the formation of the earth. These processes were continuously active, and these processes have changed the surface of the earth, and it is currently changing the surface of the earth, and it will change the surface of the earth in the future also. Now, as a civil engineer, when we are going to do some kind of activities, some kind of construction activities, what we are interested to know that what kind of processes were acting on this particular location where I'm going to consider for a construction, and what are the things which is going on, what processes are going on, and what kind of processes we can expect in the future. Just for an example, if I take the last figure with what is seen here, here you can see a river which is flowing. The river is now eroding the banks. So as a period of time, the river may erode further and the curve may become more curved, and this part where the inner part it is depositing, so that may become further proceed further towards the river side. Or in case of a dune, if you see, this dune is still not stabilized dune, and after some years if you see this dune may move further ahead. So there are chances that the dune may move further ahead, and this plant or the tree what you are seeing here, it may completely covered by the dune. And if you are planning to construct a building in front of this dune, then we should keep in our mind that there are chances that dune may further move ahead. And this is what it is a effect of an earthquake, what we see on this image. Okay, so this is what a general idea of the physical geological portion what we are going to cover today. Now, what are the things we are going to study? We are going to discuss about the activities of natural agents. What are these natural agents? On the left hand side, if you see, these are the glaciers. Glaciers are the large solid ice sheets, moving ice sheets. Then the groundwater, which is below the surface of the water, and this is streams, which is flowing water, and these are the oceans and sea, that is the water stored in the oceans and sea. So these are all processes which are basically 4 processes which are basically active by water. Then on the right hand side, if you see, there is the process by atmosphere. Atmospheric processes includes the weathering, which erodes something, which changes the color or something. For example, if you see a rock which is laying on the surface for a longer period of time, so that will change the color of that rock. So that is a process done by the atmosphere. And there are processes by wind. wind blowing deposits that we have seen. The dune, which is a wind blowing deposit, and there are a number of other features which are produced by the erosion of the wind. And the mass movements is a term which is used for the downslope movement of rocks in under gravity, or in general term you may be aware about the landslides. Okay, landslide is only a one type of mass movement. There are a number of other type of mass movements. Landslide is one type. We will discuss that in detail. So these are the main 7 natural processes which are going on our surface of the earth. As a result, what happens? It changes the surface of earth, or it changed the surface of earth in the past and changing today, and it will change in the future. So as a civil engineer, when we know that, okay, what processes are acting on my particular area and how is it going to affect my structure, that is what our main purpose. So to give you an idea of that, what I'm thinking, that I'm going to take 3 examples from Gujarat, what I have personally seen. Okay, one is Bharuch Canal construction, which was happened around 2009, and another one is a residential complex or a residential society located in the Wasad, that National Highway Bridge, just beside the National Highway Bridge. And third one is our river Sabarmati riverfront project. So I'm just going to see these 3 projects, 3 things, which is one is a private project and 2 others are government projects, and we are going to see that, and geologically what I understand from this processes, these 3 projects. This is very important to understand these 3, the concept what I'm going to discuss right now. So let us take one by one. Okay, so what I'm going to take first is the Bharuch Canal. For a real life example, what I'm going to present here, and this is actually the process which happened somewhere around 2009. And the story of this process, which started in 2009, May 28, there were a news report in Times of India, and the title of the heading title of the news was Bharuch pulls Narmada back to right bank. Okay, so when you go through the details, what it is written here, we can see, if you are able to see the figure here, on the left hand side you see a Bharuch city, and in the right hand side what you see here, it is the Ankleshwar, and in between we can see a large amount of deposit by river Narmada. As a result, what happened? Narmada water is now running far away from Bharuch city. This is what the reality, what you have, that the Bharuch administrators have noticed. Okay, so they noticed, okay, now right now the Narmada is flowing far away from the Bharuch city. It is correct. And what they thought of, okay, let us bring this Narmada back. What you see on this part, it is the Narmada bridge, that is the golden bridge. What these people, the Bharuch people have thought of, that the municipality of Bharuch, they have thought of, they thought, okay, let us bring this Narmada water towards the Bharuch side. And what they have planned? They have planned to produce a canal across these deposits, and they thought, okay, if you cut a canal here, the river will start flowing through that canal. And I was doing PhD on this area during that time, and I read this news, and I just opened the maps and all. I did a small, so this presentation goes something like this. This is what the general geological character of a river. Now if I see the Bharuch, what you see here, this is the Bharuch city, and what you see on the opposite side, it is the Ankleshwar, and this is where the river Narmada now flows. The red line what you see on the screen, this is through which the river Narmada flows. Now as per the Bharuch municipality, what they have observed, the river Narmada is now flowing far away from the Bharuch city because of this deposit what you can see here. And this deposit, in geological terms, we call it is a bar deposit. Bar deposit means it is a huge amount of sand deposited by a river. And they thought, okay, they will make a canal over here, and that will solve the purpose. So they started constructing this canal on this part. Now, when I analyzed this area, what I did is that I analyzed that in what is the characteristics of this region. So if you see from this part here, the river is directly hitting on the bank. As a result, what happens? It erodes materials from here. Similarly, it's all this curve what you have seen in the blue, which are the areas where river is eroding continuously. And this part is also it is eroding, whereas in the yellow part what you see is the part where the river is depositing means river is putting the eroded material. Simple process. When the water flows, it cuts from one part and it cuts in the downstream or in the other part, somewhere where it gets a lower energy condition. So when I say it simply, we analyze that okay, this is the part where it is now as a deposition length for this river, and these are the blue lines are the areas where there is a erosional end for the river. And I compared that then earlier this river was flowing towards Narmada, towards Bharuch. Earlier it was flowing here. Then I started looking into that. Why people are saying that earlier it was flowing towards Narmada, towards Bharuch, and now it is flowing away from Bharuch. What I did, I took the older maps. So this map what you have seen on the screen, which is a topographical map of 1972. Okay, around 35-40 years before. This was the situation. And here if you compare the situation, you will be able to see the river was flowing more towards Bharuch. That sand deposit was not there. It's true. Whereas what was the change we observed? We observed the change. The river is now flowing on this road, which is towards the northern channel. Okay, as of today, the major flow of the river on the southern channel, but if you see on 1972, the river is flowing on the northern channel. And this deposit, which is the in between what you see is the deposit, this is our Kabirwad, where there is a temple, and some of you must have visited that also. And this channel now it is almost closed, and the river is flowing basically on this part. This is closing now. So such kind of changes are there. Where is the change? The changes in this part of the river. Earlier river was flowing on northern channel. Now the river is flowing on southern channel. As a result, the changes were happened where erosion deposition areas were also changed. So if I compare these two areas together, overlying the earlier 1972 situation to this present situation, what happens? We can easily see in 1972 here there were a large depositional part that converted to a erosional part here, and when it converted to erosional part here, this erosional or sediments which was depositing here, which started to a erosional end. Deposition, erosion. So that changes which is happening in the river. And after going through all this simple analysis, it's not very complicated analysis, it's very simple analysis, I came into a conclusion that even if we construct a canal on this part, cutting across the sand, it is not going to survive. I'll tell you why. Because unless and until we change the channel of this part will still remain as a depositional end for the river. And as long as this part becomes a depositional end for the river, whatever channel you make on this sand, it will be deposited, the river will be depositing sediments on that channel and it will fill down. You got the point? As long as if you are not changing the channel of this part of the river, the bar part of the river, if river is still flowing on this part, till it is flowing on this side, this part will become a depositional end for the river, and this part become a erosional end for the river, and this part become a erosional end for the river. So that will continue as it is. So this is not going to survive. The construction of canal is not going to survive. That is what one point I noticed, and I presented that okay, if you are going to construct the canal here, it is not going to survive, because Narmada river is so much capable to fill a small canal what a human can make on the river. So it will fill in an year or two, it will easily fill that canal. And in case, chances are less, but in case If it survive, then also we are going to be in trouble. What is the trouble? Because this Bharuch city is around 40-45 kilometer inland from the sea, and all water what you are see here on the river, this is saline water, and Bharuch city is already facing a saline water intrusion from the river. So the water which is below this Bharuch city where we make a borewell, that is now getting more and more saline. So I told the collector, and if you are going to construct a canal and if it is surviving, is going to be more dangerous for people around the Bharuch city. It is not going to survive, that is the fact, but there are 1% chance if you take it survives, then that will be more difficult for the Bharuch peoples who are living here, because this water is saline and the salinity will increase, and the water where you are using today, the borewells what you are using today, will convert it into a saline water and you won't be able to use that. So these are some of the other things what you have presented, and finally I presented this concept to them with this kind of thematic maps and all. And this was the channel, and this is the bar deposit, sediment deposit. This is a cross-sectional view what you are seeing. This is the channel, and if you made the canal, then what is the problem? This channel will either fill, and this will become a point bar by filling, or it will start infiltrating. If you are putting this saline water more towards the city, that means more saline water intrusion will be there, more saline water, fresh water will be drawn back. So a simple general idea about geological situation or the river dynamics would have avoided avoided this construction of canal, and we should have saved some money, public money. Now let us take the second example, Wasat Bridge on the Mahi River. Okay, so if you cross this river in the evening time or any time, if you are moving from Anand to Vadodara, if you when you cross this bridge, if you look on your left hand side, you will see a beautiful bungalows here. Okay, so this beautiful bungalows what you are seeing here is what as per me is a unscientific construction. Okay, so I'll tell you why I'm saying this is unscientific for me. So you can see these buildings. There are around 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So around 26, around 30 bungalows are there, and they call it is a riverfront project because it is just in front of the river Mahi. It's a beautiful river. It is no problem. But if I make a cross section across this area, starting from this is one part of the river, and this is another part of the river. You can see this line what I have drawn. Okay, so I'm going to name that line, which is okay, I already made that line. Okay, so this line you can see the white line which is connecting one part of the road to the another part of the road. So the road is almost on a same level, same height, and when I take a cross section across this line, let us make a cross section, show the elevation profile, and now if you see the height of the road, you can see the arrow moving here on the road also. The height of the road here, it is 33 meters, and if you come here in the bank where the site is located, you can see the meter, it's 24 meters. Okay, so this is where the buildings are located, around 19 meters to 24 meters. In contrast to that, if you go to the opposite bank, what is the height here? 37 meters. What is the height here? This is 23 meters. So there is almost 14-meter height difference between these two parts. Now you just imagine a situation where there is a flood and water is filling this. Water fill up to this level, that is around 20 meter, and when the water increases, the water is going to easily get into these buildings or the residential buildings. not satisfied. Let us take, I'm taking this same line, I'm going to save this, save place source, was 2, save, and I'm going to open that line here. In this is called a SRTM image, what you are seeing right now. SRTM is called Shuttle Radar Topographic Mission. It is a digital elevation model. So I'm going to open that file just I have opened, that I have created. Line style, use solid color. Let me make it into white color. Okay. Line, solid line, 2 pixels. Okay, apply. Okay. Are the line I have drawn here on the across this river. Okay, it may be seen little small because this scale is, this is highly zoomed and this is not that much zoomed. Okay, so this is the area where we are talking about the Narmada, the Mahi river, and in this where we are constructed our buildings. Now what I'm going to do is that I'm going to see the 3D view of this. Okay, so this is how the river will now look like. This is where the line is that across cutting the river. Okay, now what I'm going to do now, I'm going to fill some water on this river to imagine that if, okay, how much level if I fill the water, what area will come under water, or which area will come under water. And please note that this image what you're seeing right now, it's slightly exaggerated. Now let us see, I'm going to fill the water. Okay, now water is flowing on the river, almost bank full recharge, almost filling the river. Now if I increase the water one more, increase the water one more, you can see this area where the construction, that area is already under water, whereas the opposite bank is not going into the water. Now if I increase one more, now still this part is not underwater, but almost the first floor of the building will be underwater. So to do a little bit of more calculations, I can understand that which part of this area will go underwater. Okay, so as far as my understanding, as far as my analysis is concerned, the building what you have constructed here in the bank of this river is really a wrong consideration as geological point of view. This is what I'm talking about in the normal flooding condition, normal every seasonal flooding condition. And if you are getting a major flood means that we happened in the last couple of years in Kerala and all. If you have seen the newspapers, the major floods that happens in once in 100 years or once in 200 years. So that kind of floods, if it is happening, that all building will go, everything will go underwater or everything will filled by sediments. So that is the trouble. That is the trouble what I'm talking about.